Alright, we're doing 5-6, which is squares and square roots. And I want to start by talking about perfect squares. So if we were to go through and draw a square, if I were to draw a square in here, something like this, and I don't know if I do this in the notes. Okay, that leaves a lot to be desired if we're going to call it a perfect square. But anyway, in talking about what squares, perfect squares are, this will work for our purposes. But if I were to say each side of this here is a 1, if I wanted to find the area of that square, I'd have 1 squared, or 1 times 1, which is 1. I could go and change those to 2's, and when I do that, now if each side is a 2, 2 times 2 is going to be 4. So 2 squared is 4. If I were to make both of those sides 3, 3 times 3, or 3 squared is 9. So perfect square is going to be these numbers and continuing on. So 4 squared would be 16, 5 squared would be 24. So 1, 4, 9, 16, 25. I think I might have said 24 a minute ago. Those are all going to be perfect squares. So what perfect square is, the definition then, I'll switch to red for dramatic emphasis, is that it's going to be a whole number. So a whole number is a number without a decimal point squared. And we could say example then would be 1, because that's 1 squared, and then 4, 9, 16, 25, 36, 49, 64, and so on. And if you wanted to, for some of those, you could write in 2 squared, 3 squared, 4 squared, and so on. So you could do some of those if you wanted to. Another way that you could look at it, I'm going to flip this over to a different color, but if we were to say these numbers here, if I wanted to get from 1 to 1, or from 4 to 2, or from 9 to 3, you could say the square root of a perfect square equals a whole number. So you could say square root of a perfect square equals a whole number. But basically, the real definition, I'd stick with this part here in red. A perfect square is going to be a whole number, a number without an integer, without a whole number without a decimal squared. Whew, it's not pretty today. Sorry, it's early. All right, square root. So jump down to square roots. So square roots kind of did that just up above with those blue things. A square root, so I'm going to put in the radical sign. So that's kind of the notation they use for square roots. Oh, I should back up a second. When we're talking about squares, if you want to punch in something like this more easily on your calculator, most calculators have a button that says x squared, and when you do that, it'll automatically square it. So you could say to that button and then equals, and that'll give you the 4. That'll do the 2 squared. You could also do, most calculators, scientific ones will either have like an x to the y or a y to the x, or they'll have this caret. So you could say, all right, if I want to do 2 to the second power, this would be my 2 exponent, and that would be the second power, and then you could do your equals. But if that doesn't make sense, let me know in class. I can probably figure out how to punch it in without too much difficulty. All right, so square roots. So square root, that symbol is going to be right up above your squared key, up above this key on your calculator. So most calculators, you're going to have to press your second button and then this x squared button to get a radical like this. And we had looked at earlier on that if we have a square, so let me fill this thing in the rest of the way, if I have a square that the side lengths are 3 like this, the area is going to be 9, because 3 squared gives me 9. Well, if we want to do that backwards, if you know the area of a square and you want to figure out the length of the sides, you could use that square root key to undo the inverse of doing the square. So I could say the length of the side of a square with an area equal to that number. So in other words, I'm going to jump down to these equations here. And I think it might make more sense if you actually use your equations. I'm going to actually write out the equation. You don't have to necessarily show all your work in these, but where we're coming from is, back in the day, we talked about the area of a square. Capital A for area is going to be the length of the sides squared. So if we were to go through and say, all right, my area is 49, so I'm going to put my 49 underneath my A. And if I want to figure out what the length of the side is going to be, it's kind of like when we were solving equations before. If we had instead 2s equals 49, we'd divide by 2. And that would cancel that out and give us the side length as, what would that be, 24.5. But it's not 2 times, it's squared. So the square root then is going to be my inverse of squaring. If I do something to one side of an equation, I have to do it to both sides of an equation. It's kind of like this square root sign here cancels with that exponent of 2 and just tell us that, okay, the length of the side is there. Square root of 49, if we punch that into a calculator, it's saying what squared, what times itself gives us 49, so that would be 7. So in other words then, for this square, the length of the sides all have to be 7. We could do the same thing for this next one. It just won't work out quite as pretty because we don't have a perfect square. 30 is not a nice whole number or an integer squared. But we could do it the problem the exact same way. The area is going to be s squared. Right? The area we know is 30. So 30 equals s squared. Well, we want to undo squaring. They squared s. We want to undo squaring it to get s by itself. So we square root it. We have to do that to both sides. And if you want to, you could cross out your square root, the radical, cross out your square. And then if we punch square root of 30 into a calculator, that's going to come up with approximately, so maybe I'll do the squiggly equals for approximately 5.48 with a little bit of rounding in there. So that's really kind of the gist for today. I got some learning targets kind of down there on the bottom, so you can look at what should you be able to do, and we should have pretty much covered all those things. So if you have questions, let me know. I'd be glad to help you out. Otherwise, kick butt and take names. Have a good one.